Good afternoon, everybody. It's Jake Thorne, and as you can see, we're working in the lab this afternoon. We're working on fecal egg counts. Now, you've probably heard Reed and I mention that before, or talk about parasite resistance, or post something about parasite resistance, but how do we measure that information? How do we quantify that? Well, we actually do that with fecal egg counts, and that's what I'm going to walk you through this afternoon. So about the 1st of June, we weaned some Dorper ewe lambs. They were dewormed at that time, and they were turned out on pasture to be challenged against parasites. And then 45 days later, which was actually the first part of this week, we started to see some evidence of parasitism in those ewe lambs. So we went ahead and collected a sample from everybody. We're going to read that, and that's going to allow us to determine the genetic propensity or the differences in those animals for parasite resistance or prevalence in this case. Okay? So how do we do a fecal egg count? Well, I've got all this stuff out here, and I want to walk you through that process. So as you can see, we've got some baggies here with the individual samples. They're labeled with the animal's ID tag. And the first step is we're going to weigh out 2 grams of feces. So that's what I've got here in this cup, just some pellets. And then we're going to add some salt solution. Actually, 28 milliliters is the exact amount. I've got that marked here on this cup from previous work. We're going to add that in there. And then we're going to take a popsicle stick and we're going to mash up all those pellets. The reason that we're going to mash these pellets up is the eggs are actually within the pellet and we have to free them or break them out. So we're going to turn this into a completely liquid solution, hopefully with an even concentration of eggs throughout. We're going to mix it up really good, and then we're going to take a pipette, we're going to draw up some of that fluid, and we're going to put it on a McMaster slide, which is specifically designed for fecal egg analysis. So this McMaster slide has 2 sides. Each side has a little green grid on it, and that's going to allow us to accurately count the same area for each animal. So I've got that loaded on there, as you can see, okay, and we're ready to go. We've actually got one already loaded here behind Reed that we're going to show you. And so what are we looking for? We're looking for specifically Haemachus contortus eggs. Haemachus contortus, or the barber pole worm, is the most damaging parasite to sheep and goats, particularly in this region. They're very prolific, and so we're going to count the number of eggs within this green grid, and that's going to give us an idea of, or an estimation of, the adult worms that are actually harming the animal within its abomasum. Okay? So I've got a little chart here that's got some various parasite eggs on it. They range completely in size. Some of our coccidia are very tiny, and then we've actually got a really big one, a nematodyrus. But we're looking for Haemachus contortus, which is kind of football shaped. It's got some little cells inside there, and it'll be easily recognizable when we get it up on the slide. Okay, so we've got this kind of fancy microscope here, but it projects what's being magnified. And I told you about the green grid. Well, that's what you're seeing right here, this green line. And that's going to allow us to go down one row, count the number of eggs, move over to the next row, count the eggs there. And then what we're going to do is we're going to multiply that number, the total number of eggs that we get, by 100. I mentioned that this slide is actually 2-sided. For a more accurate analysis, you can count both sides of that slide and multiply it by 50. And that's going to get us our eggs per gram. Okay, let's take a look. Okay, and if we scroll down this chamber, there you go. There's 2 nice Haemachus contortus eggs right there in the center of the slide. As you can see, they have a really defined border, and then you can see that interior material. Don't want you to get those confused with air bubbles. See if I can find an air bubble, or even vegetable matter. That's what this darkness is here. They actually are easily distinguished from those things. Oop. There's an air bubble. There's a nice kind of dark circle. That's not what we're wanting to count. We're wanting to count just those Haemachus eggs. Okay? So this information, what are we going to do with it? Well, I've actually got here on this sheet from all those ewe lambs that I mentioned a variety of egg counts, and there's a lot of variation. We have anywhere from 100 to 200 at our lowest, which is a low amount, to up over 25,000. About 10% of these animals are showing a severe infection, and we anticipated maybe seeing this, so we had treated all those animals when we collected these samples. But this information will be really valuable to us. And it'll be valuable because we're going to put it into the National Sheep Improvement Program software based off of that animal's performance or phenotype in this case, which is its egg count, the performance of its relatives. We're going to develop percent fecal egg count EBV. And I know, I apologize, it's really small, but that's actually what I've got on this sheet here are some PFEC EBVs from our lambs from this past year. And I highlighted 2 individuals, and if you can't see it, I'll go ahead and tell you that this top animal here has a fecal egg count EBV of -14. So your first reaction might be, oh, negative, that's probably not a good thing. Well, in this case, we want a low number. That reflects a low amount of eggs expected in that animal or in its offspring samples. Okay? Then below it, I've highlighted another one. It's got a +45 fecal egg count. And so this number, this fecal egg count EBV, actually represents the percentage of eggs that you would expect in the feces of these animals. Okay, so a -14 represents a 14% less amount of eggs than average you would expect in this in the offspring of this animal, whereas on the +45 would be 45% more eggs. So that would be a bad thing. So this information is really valuable to us. Obviously, parasites are very damaging to sheep and goats here in the state of Texas. We're experiencing an extremely bad parasite, or good for the parasite year, but we're seeing tons of infections. So those animals that are genetically more resistant are going to thrive better. They're going to end up being more profitable, and so that's a really good thing. This kind of information, we've got all the supplies here. It may be a bit tricky for you to do at home, but the AgriLife Center is actually going to be offering this as a commercial service to the industry here in the near future. For a few bucks a sample, you can send in your samples. We can give you egg count numbers, and you can all go ahead and enter your own information in NSIP if you wish. Well, we're not offering a diagnostic service, which type of parasite. That's not necessarily the case. We want to give you some numbers that reflect parasitism amounts within your animals, and that'll allow you to select for those animals that are more resistant. So hopefully this was helpful. Hopefully this was informative. We'll post some things in the comments about maybe some of the supplies and where you can get it. But if you have any questions, feel free to ask away. Thank you and have a good day.